Uh, I have recorded yesterday's class, but it will take some time to post it because I'll be busy throughout today and tomorrow also. So by this weekend, I'll post yesterday's class and also today's class. So don't worry if you don't get it immediately. Yeah, Vaibhav, please.
Yes, sir. Am I audible?
Uh, Over audible.
Okay, sir. Sorry.
No,
My question was regarding that question number five from Hoy. Can I solve that graphically, or is it compulsory to solve it means through that equation?
that's average cost, right?
Yes, sir. The one we did yesterday, the last sum we
Yeah.
did yesterday.
No, you see, Hoy is asking us to find out the exact Q, whether it is, let us say, 5, 10, 15, whatever. So if you do it graphically, you won't be able to find out the exact value of output.
Sir, but I plotted the graph. It obviously came to be a parabola, and the price was constant. That is a line parallel to the x-axis.
Mm.
So, sir, obviously there was no break-even point, as you said. Through the graph also, I got no break-even point, and they asked the output levels at which they would make a loss. That would
Yeah,
be any price,
all price. Mm.
all prices below $20. That would be the answer, I guess.
No, no. Here, over here, it's all prices.
So,
Oh, sorry, all output
the
levels.
vertex of the parabola came to be at $20.
It came to 20.
Yes, sir. And the price was $10, so there was no break-even point. And at any point
Okay.
below $20, the firm would make a loss.
Uh, what was the exact question? Was it price or output? Let's say 59 over. Oh, over what range of prices does the firm make a loss at all output levels? Yeah, in that case, it's any price below 20.
So I can do this one graphically, right? Or should I follow the equation one?
See, if you do it graphically, you
Hmm?
will have to plot a lot of points
Yes, sir.
and
That
use
is
a
true.
graph paper.
Yeah. Okay, so
But
it's better to do it that way.
yeah,
Okay, sir. Got it. Okay, sir. Thank you, sir.
yeah. So that's okay. Can you see the screen? Monotone?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Just a minute. Let me shift this. Okay. So I'm just going back a little bit. So we can have a sequence which is either increasing or decreasing throughout the range. So if it is increasing, we call it a increasing monotone. And if it is decreasing, we call it a decreasing monotone. This pass, the last two lines. So in case of increasing, the A1 and A2. A2 is either greater than or less than. Okay. So it is, uh, see, so far it is an increasing monotone. Here it is constant, but it is not falling. So we call it an increasing monotone. And this part where it is strictly increasing, it is called strictly increasing monotone. Similarly for decreasing monotones. Here it is constant. So it is simply a decreasing monotone. But here it is always decreasing. And in this case, we can't say it's not a monotone, it's an oscillation. Now, the theorem which I wanted to start off with, I broke off at this point yesterday, that if we have an increasing sequence, we have an increasing monotone, and it is bounded from above. Such a sequence, The theorem states that such a sequence will converge towards its lowest upper bound. Uh, suppose we think of a mm, let us think of a finite series 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it stops. Okay. Arpan, are you there? Can you unmute yourself, please? Yeah. Okay, Arpan. So we have a series which starts from 1 and it ends at 9. Okay. Can we say that 10 is a boundary of the series?
No,
Why not? Open boundary?
because
What is
it
an
doesn't
open
lie in
bound?
the set.
What is an suppose we take a open interval? That
Mm,
means the set will not touch the boundaries.
yes,
In case of a closed interval, you touch the boundaries. So it will be
yes,
equal to 10.
yes, sir.
Right. So this is an open interval
Yes, sir.
and 10 is a boundary. What is a boundary? It is all values are below this. Right. Now can we say that 12 is also a boundary?
Uh, I don't know
Acha, how will you define a boundary?
if it like it is the last. It comes inside it and on it.
No,
The
think
set
of it in the reverse
like
way. Look at the sequence. What is the last number in the sequence? It is 9.
9.
Right. What is the boundary?
Yes,
Is it greater than 9? If you're talking
boundary is I
about
think
an
9.
open boundary, it has to be something
Yeah,
which is
greater than
above 9, greater than 9. So 10 is a boundary.
yes,
So the entire
yes,
sequence must lie below the boundary, right?
yeah.
It is something like this. If you think of a number, if you think of a number line, this is an open interval. Let us say this is 10. This is 1, 2, 3, and up till 9. So the entire series A1 to A9 is below 10, right? So we can say that 10 is a boundary. What about 11? Does the same relation hold? Does
Yes,
the
sir.
same relation hold as we have written over here?
Yes, sir.
Yeah.
Yeah.
So, okay. So 11 is also a boundary. 12.
Yes. Yes, sir.
Okay. So a set can have a large number of boundaries. Okay.
Boundaries.
Okay. Arpan, you can mute yourself now. So we have a large number of boundaries. But what is special about 10? It is the lowest bound. Okay. Similarly, if I look at the series 1 to 9, what is the lower boundary?
0.
It can be 0.
0.
Okay. -1. -1 also. So all these are upper bounds and these are lower bounds. But again, what is special about 0? It is the highest lower bound. See, we can say that the boundaries of the set is -100 and +100. Okay. But does it really precisely define the set? It doesn't. Because if you look at it, it may appear that -99, 0, -5, 20, all these are part of the sets. So when we define a set or a sequence using boundaries, we generally used the highest lower bound and the lowest upper bound. So we will say that a set is bound by 0 and 10. Okay. So although a set may have many boundaries, we generally focus on the boundaries which can really effectively define the set, which is 0 and 10. Okay. Now the theorem says that a sequence will converge towards its lowest upper bound. That means in this case up till 10. So what's the proof of this? So suppose that we have a sequence an and it increases and the upper boundary is b. So we have to prove that an tends to b as n tends to infinity. Now let us take a very small neighborhood, epsilon. Okay. So basically what we are saying is we have got b. See, when we want to define a neighborhood, the numbers on either side of b, we have to say how many points we are taking or what is the radius. So we have to take this is the diameter. And what is the radius? We call this epsilon. Instead of epsilon, we could have used any other symbol, but Hoy is using epsilon. Okay. So B is, so we take a neighborhood epsilon, which is positive. Therefore, B minus E epsilon is not an upper bound. See, look at this set. This is the upper bound. What is B minus epsilon? This side or this side? Right or left?
Left side.
Left
Left
side.
side.
Left side.
Okay. So this is B minus epsilon. So the series is increasing like this. So we had said that B is the lowest upper bound. Now, can a point like this, see, this is also within the set. We can define a point like this, which lies between B and B minus E. This is part of the set, part of the sequence. So what we're saying is that if B minus epsilon is not a boundary, then it should have some points in between. Now, an is an increasing sequence. So for any n, greater than n, we will have, sorry, it's a typo. We will have this relation, right? See, we are defining sequences as okay. So if we take m, if m is less than n, we should have this. So for any n greater than m, an is greater than equal to am. So for any n, remember an was defined as greater than b minus epsilon. We will have an greater than equal to am greater than b minus epsilon. So what we are saying is, let me take this point. This is b minus epsilon. If I have n, what is the location of an?
Left hand side of AN.
It will be either on this side, if it is a strictly increasing monotone, or if it is just an increasing monotone, it can also be equal to an. Right. So it's strictly increasing monotone, and if it is simply an increasing monotone. So we can write this relation an greater than equal to am, which is greater than b minus epsilon. Now, b is an upper bound of the sequence. Therefore, an cannot be greater than b. See, we can shift an over here. We can shift an over here, but at the most it will equal to b if it is a closed interval. So what is the maximum value of an?
B.
B. It is assuming that it's a closed interval. Okay. So for any n greater than n, we can write b minus epsilon less than an, which is less than equal to b. Now, if I add an epsilon to b, this will become, instead of the weak inequality, it will become a strong inequality. And this simply means this relation. The absolute value will be less than epsilon. So given any epsilon which is positive, we have found an m such that for any n greater than n, this relation holds. Therefore, as an tends to b, so we are gradually moving towards b, n will tend to infinity. Now, from this we go to the concept of limits. Now we can have two types of limits, left limit and right limit. Uh, have you done this in your class, maths classes at HS? You
Yes,
know
sir.
what is a
Yes,
limit,
sir.
Sir.
Yes, sir.
left limit, right limit, you know. Okay. So you can have a look at this definition. It's from, I've copied this from Hoy. This is a slightly easier definition. So what we're saying is that we have an open interval AB. You can see over here, it's an open interval. So that means A and B are not part of the sequence. So we have defined a function within this value. See, this part, beyond A, below A, this is not in a discussion. We are only concerned with this part of the function. Okay. So we say that f converges or tends to a limit L as this is the x-axis, as x tends to b from the left. So x is increasing. So technically, as x tends to b, x increases and it approaches b. So this negative simply indicates that you're approaching from below. In that case, fx will tend to L if the condition is satisfied. Given that any epsilon positive, we can find a positive del such that the absolute value of this difference is less than epsilon. Given that beta minus del, x lies between beta minus del and b. Okay. So basically what it means is that we have drawn a function over here and we have taken an interval a, b. Okay, we take a del, which is positive. So beta minus del, the interval is del. Okay. Okay. Now we take any x, let us say x1, within this interval, beta minus del and b. So that means this condition is satisfied. Okay. So here we will get the functional value fx1. So the difference between fx1 and L will be less than the epsilon value. When epsilon is basically this, the difference between fb and fb minus del. Similarly, we can define the right limit. Here the function is increasing and we are focusing on the lower bound. So what is happening over here? We take the lower bound, which is a, and we add a small number, del. So a and del. So a gives the limit, and this is f of a plus del. Right. So if we take an x1, any x within this range, we will get fx1. So the difference between fx1 and L will be less than epsilon. Okay. So if you look at these three figures, you can see that this is continuous at epsilon at this point. Over here, fx is, we can say it's continuous. Uh, sorry, this figure should come later. Okay. So the next thing that I want to discuss is asymptote. See over here, the function is going up. This is x equal to 0. The function is not defined as at x equal to 0. What is happening is it is asymptotically approaching the y-axis. So here it is approaching the y-axis in the negative quadrant. Here it is approaching the y-axis at in the positive quadrant. On the other hand, over here, we can see, now in both cases, you can see that the direction is the same. Here, you can see that the direction is opposite. So as x is going up, we are moving towards the right limit. We are approaching minus infinity. Here, as we are approaching the left limit, it is approaching plus infinity. In both cases, what is happening is that the function becomes unbounded or undefined as x approaches some value, x equal to a. Here, x is equal to 0. Here, x is equal to 1. Okay. In that case, the line x equal to a is the asymptote of the function. We say that a function asymptotically approaches a. Next, we come to continuity. See, so far the focus was on how the function behaves when x tends to some point tau, but not on what happens when x is equal to tau. Now, it is possible, as you have seen immediately, that a function fx tends to a limit L as x tends to tau, even if fx is not defined at x equal to tau. This is the earlier case. The function tends to a limit x equal to 0, even though f x equal to 0 is undefined. This case. Here you can see the opposite. What happens is the function is defined at x equal to tau, but there is no limit. Okay. Now suppose that fx is defined over an interval ab and tau lies within the interval. So we say that a function is continuous at a point tau if and only if fx tends to tau as x tends to tau. Okay. Overall, a function is said to be continuous at a point tau if and only if fx tends to f tau as x tends to tau. Okay. So basically, it means that a function is continuous if the graph of the function does not have any break or jump in it. See over here, it is continuous over here. But at this point, there's a jump. It jumps from here to here. Then again, look over here. It is continuous in this range. Now there's a fall. Again, it is continuous over here. So it is continuous. If you consider the open interval, LAB, it is continuous. If it is continuous at every point, at any point over here within this open interval, then we say that the function is continuous within this interval. If it is a closed interval, the function fx is said to be continuous if it is continuous at all points within the interval. It is also continuous to the right of a. Sorry, it will just opposite. It's also continuous. No, sorry. Yeah. Yeah. It is continuous to the right of a. So this is the right of A. It is also continuous to the left of B. So over here, basically what we are seeing, it is continuous at all points within the open interval AB. It is also continuous at x equal to A and at x equal to B. In that case, we say that the function is continuous in a closed interval. Okay. So this and this is the same. The only difference is why we are saying that this is discontinuous. It is because if we define this as a in an open interval, we are simply looking at internal points. This is a closed interval. We are looking at x equal to A, x equal to B, and all x's lying between A and B.
Sir,
Yes.
sir, shouldn't that be left of A and right of B? The second case.
Uh, okay, just a minute. I'll just check.
Okay, sir.
A function f is continuous on an interval AB if and only if it is continuous at each point in AB, the open interval, and also continuous at the only difference is on the right of A and on the left at B.
So basically at A and at B, right?
Yes. So in this case, we should not include the points A and B. Here we are saying we should also include A and B. That is the difference. We are not interested in what happens over here. Okay, so this is the technical definition that the left limit and right limit must be same, and fx should tend towards the limit b. And obviously, if a function is not continuous, it is said to be discontinuous. So in this case, it is function over here, but there's a break over here. So it is discontinuous at this point. Okay, so these are continuous functions. You can see that there's no break. No, just 1 minute. These, on the other hand, are discontinuous. You can see there's a break over here. The line comes here, and then it comes over here. Here, the function approaches the y-axis asymptotically. This also approaches the y-axis asymptotically, but the function is not defined at x equal to 0. Over here is almost the same thing as this one. The only difference is they approach different values. Here we approach positive infinity. Here we approach negative infinity. This okay. See over here, what happens is, see, this is a straight line. Now, at this point, see, fx is equal to 3x. Okay. So that means if f is equal to, let x is equal to 1, what should be f? It should be 3, right? at a value of 2, what should be fx? It should be 6. But we have said that it is not, if x is not equal to 2, then only it is 3x. And if x is equal to 2, it is this point. So we go along this line up to here. There's a hole over here, and then the line continues. This hole actually comes over here. You can see there's a small circle over here. That is why it is not continuous. But if you go back, see, there's no hole over here. Okay. So is this clear? So there must not be any break, or we can say there's a kink over here. The function should be defined. In these two cases, the function is not defined. Over here, there's the point shifts to a different space. There's no continuity. Okay. So now that we have discussed these concepts, let us go and try to apply them. The first application is not very, original or very thought-provoking, but still, let's discuss it. Production. So suppose we have a production function where you have got only one input, which is labor. Now suppose the production function is no, we can't have this. Yeah, let's keep this. Sorry. Sorry, it's jinxed. Yeah, now it's better. So we are producing the output using only labor. So let us say the function takes the specific form of right. Now, what is output?
0,
0,
0,
Now,
7.5,
7.5,
now,
1,
15,
15,
15,
now,
22.5,
22.5.
this will be 30,
15.
and so on. Right. Okay. Now there are two issues over here. Suppose Q is kg of rice. What does 7.5 mean? It means 7 kilos of and 500 grams. Is this possible?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
15 is highly possible. 22.5 means 22 kilos, and you just add 500 grams, right? But suppose it's not rice, it is mm, it's books. 0 books are possible. You don't buy any books. 15 books possible. 30 books. Well, it's a huge. Your course must be very tough, but still, it's possible. But what about 7.5, 22.5?
It's
So
not
they aren't
possible.
possible.
Not possible.
It's not possible. So often output may not be divisible. So technically what we are doing is when we are drawing a function like this, we are assuming that all points over here can be produced. But in reality, 1, 2, 3, 4, there are also points in between 4.1, 3.7, 3.4. So it's not possible to produce that much. So technically, when we are talking about the production function, is it continuous?
Yes, sir.
No, sir.
In case of most outputs, in case of the books, for instance, even for rice, possible.
No,
No,
sir.
sir.
So actually, when we are talking about production, the production function, we are talking about discrete points like this. For two reasons. One is the output problem. Secondly, uh, instead of uh, labor, let us assume it is capital. Let us suppose it's a software company and you're asked to enter data. Now, if the company employs has one computer, let us suppose it can enter 1,000 entries in a day. If it employs two computers, it should enter 2,000 data. If it employs 2.55 computers, what will be the data entry?
2,500.
Yeah. What is the, where can you get a half a computer?
Nowhere.
So it isn't possible.
One sec, please. Yeah, so 2.5, it's not possible. So similarly, in the case of labor also, we are using exact discrete points. 1, 2, 3. We can't use 1.5, 1.75. It's not possible to apply this. So the discontinuity in production is partly because labor itself is not perfectly divisible. It is indivisible. It occurs only in the input applies in discrete amounts. And secondly, see, even if you put 1, 2, 3 over here, even then, some of the output may not be feasible. So partly because inputs are not divisible and partly because outputs themselves are not divisible, what we get is a set of discontinuous points. So talking about production functions is actually meaningless because you don't have a continuous function. But for analytical convenience, we assumed that all points are feasible. Have you ever been to Big Boy? Is there anyone from Assam in this class? No. So has anyone been to Big Boy? Do you know how the name Big Boy was generated? How it came about? Okay. So you know what Big Boy is famous for, don't you?
Yes, sir. There's an oil
Oil
field, I guess.
City.
So there was a European who was traveling in the forest with an elephant, and suddenly he saw that the soil had become very soft. And when the elephant trod on the soil, the story goes, oil apparently came out. Something oily came out. And apparently he got so excited, he said, "Dig, boy, dig." And then the name of the town became Dig Boy. And well, what is interesting about Dig Boy is that they had, in the oil factory, they had, uh, the workers had a trade union. And do you know who the largest member of the trade union was?
The elephant.
Well, not that elephant, but another elephant, maybe his descendant. And I mean, they have shown, they have a museum and they have pictures of the elephant. So apparently it used to start work. I mean, in all the mine factories, they have a horn. So when the shift starts, the horn blows. When the shift ends, there's again a horn. So apparently the elephant used to work very sincerely, but as soon as the closing horn was blown, whatever it was doing, it used to stop immediately. If it was carrying something from one place to another, it immediately stopped and put down the bundle where it was, in the middle of the road. So you can think of this as a case of indivisibility. He was supposed to move from here to here, but he stopped it midway. So depending on when the horn would blow, you could have an indivisible output. Okay, so I mean, this is just to break the monotony. But Digboy is a very nice town. Digboy, Margarita. Okay. And you should go to, I mean, if you have chance, you should go and visit Digboy. The museum is very good also. Now, the second example that I want to discuss is that uh, how to uh, define the wage structure. Now, you know that in most cases, you are simply paid a wage W, and this amount is paid every month. Okay, so whether you work or not, you may take holiday, you will still get W bar. Now, in some cases, uh, with the objective of providing incentives, and this particularly applies to salesmen. So suppose you have a salesman and you offer them a fixed wage of W. Now remember, the sales is very difficult. You have to move about the city. So will you, if you are given a fixed wage of W, that is every month you get W. Let us say that W is 800. So in that case, will you try to sell anything? So we say that selling involves this utility. So it is a cost on the person. So in this case, if this is the wage structure, what will be the sales of every person?
It will depend on the incentive.
No, right now there's no incentive. It's only a fixed wage.
He wouldn't sell then anything maybe.
Yeah. See, he's getting 800. If he works for, let us say, L hours to sell something, he's going to incur a cost of CL. Therefore, his net income will actually go down if L is positive. Therefore, he will not work. He will simply sit in his office and not sell anything, and the company will go to the dogs. So for this reason, incentives are provided in the form of commission. Commission means that if you sell anything, you get a certain amount. So for every unit sold, you get an amount, let us say I. Now let us assume that if you sell something, for every, to sell something, you have to devote L hours. This will result in a cost of minus C, and you get I in return. So if I is greater than C, in that case, what is your net income? It will be right. Now for convenience, let us suppose that I is equal to 10 and C is equal to 4. So that means I minus C is 6. So the salesman income will be 800, which is a flat rate, plus 6L. Okay. So we can denote the income as, sorry, it's awful. So if L is equal to 0, he gets 800. If L is equal to 1, he gets 806, and so on.
Sir, how did 6 come?
Which one? This one.
Sir, the 6 in 6L. Yeah, 800 plus 6L. How did the 6 come here?
Okay, over here, see, it is 800 plus you're getting some commission, but there's also a cost. You have to travel about the city on your scooter. So you have to pay out some
Okay.
money to pay the
Yes, yes.
scooter bills. Uh,
Okay, okay, got it.
yeah, let's make it 140. Okay, otherwise the figures are too low. So it becomes 60L. So that means if L is equal to 1, you get 860. L is equal to 2, you get 920. Mm, okay, let's make it L equal to 5. In that case, how much will it be? 300. It will be 1100. Okay. Right. Okay. Now you can give another type of incentive, which is in the form of bonus. So the people are told that, look, if you can sell more than 5 units, we will give you a bonus of 200. Okay. So in this case, what will be the, how will the function look like? Remember, the commission is still there. Just look at this. L is equal to 6. This is the fixed income. This is the commission, and he gets a bonus of 200, right? In case of 7, 800. Now, can we write this in this way? 800 and 200, which makes it 1000 plus 60L, right? So now, what will be the function? So here there's a jump. This will be 200, right? What is the slope over here?
Yeah, the slope is same
Both
only.
both are same.
Or
Yeah.
the intercept
Intercept
change.
is different.
Yeah. So in both cases, the slope is same. What happens? We move from here. We say there's a kink in the wage function. So welcome, Akankha. Akankha. Glad that you've honored us by joining even after 1 hour. Okay, is this clear, everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Sir.
Yes, sir.
Yes,
Yes, sir.
Okay. what was the function? It was, we can write this as 80 plus 6L if L is right. This is the function. Okay. Now think of three persons. There are three salesmen, A, B, and C. So they've worked for 27 days. No, they were working in February. They worked hard. And on the 20th day, A found that he was at a point like this. Okay. Then he suddenly realized that it was a leap year. So he had one more day in which he could, sell something and increase his income. Okay. So one possibility is he doesn't do any work. He just takes the last day off. In that case, his income will be over here. It is also possible that A, works more, puts in extra effort so that sales increases. And I said the other opportunity is he does not work, so his income is same. What will he do? Which option will he go for?
So sales mode.
Okay. B is at a point like this. B also is the same choice. What will his decision be?
B
Sales
should
mode, sir.
rather, sell, yeah. Then he will get a leap
Sales
of
mode and
200
income.
rupees extra.
Okay. So B will also work more. And let us say that C is somewhere over here. What will C do?
So it is same sales mode.
So each of them will work more. Now, they will work more because of the incentive through commission. If they increase L, then Y goes up, right? Now, the question that I want to ask is,
Sir, B will work harder because he has the greatest incentive.
yeah, what is the incentive to A and C? The incentive is the commission effect,
Commission.
which is simply 60 into L. In case of B, it is
Bonus plus
commission
commission.
Bonus plus commission.
60L plus 200. So what happens is, because of this discontinuity, the three persons can have different types of incentive to work more. Are you getting this point? So that if you just employ the commission, then three of them are going to work equally. But once you have introduced a bonus also, then some people can put, who are close to the margin, can put in extra effort. Okay. By the way, Kritika, I think that you have offered to be CR, right?
Yes, sir.
So do you know the responsibilities and the traditions that you have to follow?
I don't know about the traditions, but more or less about the responsibilities, I have an idea, yes.
Um, Ma'am has briefed you.
No, she hasn't briefed me actually. She just sent me a mail last night, and that was it.
Oh, she didn't mention about the traditions.
No, no, nothing like that.
Oh, the tradition is at the end of the semester, uh, the CR has to treat all the students and the Math Econ teacher to an cornetto ice cream.
Oh, that's fine. That's perfect.
Reaction from the others?
I think they'll be happy.
Yes, sir.
Of course.
Yes.
Okay. Remember that it's being recorded, right?
Yes, sir, for
It will be
sure.
recorded, posted on YouTube, and any attempt to go back, it will be spread all over the internet world.
No, sir, I'll make sure that cornetto is offered to everyone at the end of the semester.
Okay. Now coming to the third example, this is something about which there has been a lot of controversy, and this is about an income support scheme, or what you can see, it is an unemployment dole. You know that in some countries, if you're unemployed, you get a government support. Now, what is the impact of this government support? So basically what happens over here is that if you work, you will get W into L. But if L is 0, you will get an unemployment dole, a fixed amount every month. Now, suppose that wage is 15 and the unemployment dole is 750. L, this is Y, which is a function of L. So how will the function look like?
Straight line passing through zero.
Is it true?
So I
Yes,
think it
yes.
will. So 750 is fixed for L equal to 0, right?
Yeah.
So it has to have like it will not pass through 0. It will pass through 750 and then it will be a straight line.
So you mean like this?
Yeah, okay,
Yes,
yeah.
sir. Yes, exactly like that. Yes.
No. See, the issue is that if you do a single bit of work, you will not get unemployment dole. So the function is like this.
If we are only considering unemployed people, then it will start from 750, right?
And go up.
Yeah.
So it will first go down and then go up, maybe.
So will this be a continuous function in
Yes,
the first
yes,
place?
exactly. So that would be a point of discontinuity first.
Okay, so first tell me, let's plot it the hard way. Okay. At L equal to 0, what is Y?
750.
750.
750.
Right? So this is the starting point. This is 1, 2, 3, 4. At L equal to 1,
15.
15.
sorry, 15.
15.
L equal to 2,
30.
30.
okay. Now what happens at the points in between? If we assume that L is divisible, it's perfectly divisible. So that means you can have points like 0.1, 0.2. So that means the line is going to go from here. But there is going to be a space over here. There's no point over here. So it's something like this one. This one. You can see that there's a circle hole over here which comes down. Similarly, the function is straight line, but at L equal to 0, it goes to here. Only for this point. There's no kink as such. Like this. There's no link like this. And it doesn't extend over here. Okay. Now, if you're like this, actually the diagram is not correct, so don't look at this. Use this. Uh, what is the problem with this incentive scheme? The problem is that you can see there's a disincentive to work. For instance, suppose L is 20. How much are you getting?
300.
Will you work?
No, sir.
No,
No,
sir.
sir.
L equal to 50.
750.
No, sir.
750.
Now you become indifferent.
Yeah.
L equal to 51. Now it's greater than 750,
Will
you will work. So the problem is that you will work only if L is greater than 50. So if you get a part-time work, you won't work. Therefore, it creates a disincentive to work. You will work, benefits to work occurs if and only if L is greater than 50. Even at 50, it's better to sit idle. Okay. So because of this wage structure over here, people will not work unless they are given. I mean, one possibility is you can increase wages from 15 to higher levels, or you have to offer them uh, gainful work for long period. So people will work only if wage increases or L is very high, right? So some people have argued that it is better if you, instead of giving them an unemployment dole like this, what you can do is you can employ unemployment dole. You can combine this with a work tax. So now you have got two options. You accept the dole, right? In that case, 750. But now you can also work. So that means if you work, you're not going to forfeit this dole.
So, but then would that be unemployment though?
So you still call it unemployment dole. Okay. Now, so that means you're getting WL, right? When L is greater than equal to 0. So the function is really starts from, well, sorry, it starts from
750.
750. However, you also have a work tax. That means half of what you get will have to be paid to the government. So that means your actual wage becomes WL by 2.
I think it will be plus W.
Plus WL
Sorry,
by
yeah, plus WL. Okay, so if L is equal to 0, you get 750. And remember, it was W. Let us make the, okay, let's keep it as 15. So it is 715 plus 7.5 L. So 1 means you're going to get 757. Your income is going to go up. 2 means 750 plus 15. right? Now suppose L is 50. In that case, what happens? You're getting 750 plus 7.5 L if you go for the dole. But you also have the opportunity that you can refuse the dole at any point. In that case, there's no work tax. Okay. So in that case, you're going to get this dole is 0. So you're going to get just WL or 15L. Okay. Don't take this. Now consider a situation when L is equal to 100. What will you do? Find out what is income if he goes for the dole.
Sir, I will be
What is?
indifferent.
Explain.
Sir, if I accept the dole, then my income will be 1500, and if I
Wait,
do not
it is
accept the dole, then it
715.
will also be
It is
1500.
715 plus 7.5 into 100. In this case, there's no tax. So 15 into 100, 1500.
Yes, sir.
But if you make L 101,
So then I will not accept the dole.
so dole means you're going to get 1500 plus 7.5. And no dole means you're going to get 1500 plus 15.
15.
So obviously, this is better.
Yes, sir.
Okay. So here, the slope was 7.5. Once you become, let us say 100, what is the slope? See, at this
So
range,
15.
you're always going to accept the dole. Beyond this, you're going to shift to the this curve, no dole curve. So the slope becomes 15. So basically, there are two functions. If you don't accept the dole, it will be like this. And if you accept the dole, it is going to be like this. So that means effectively, it is going to be this, then this. This is going to be the effective labor function, right?
Yes, sir.
Okay. Okay. Now, since we are discussing production, let us look into the relation between marginal product total product and average product. So if we have total product, how do we get AP? We assume that there's only one input. If you know what is total product, can you find out average product?
Yes, sir.
Yes,
Dividing
sir.
by
Total
L.
product by
Yes, sir.
quantity. I mean, labor.
By labor.
Yeah. And MP will be simply DTP by DL.
Yeah.
Now let's look into the marginal product a bit carefully. Sorry, this is TP is AP into L, right? Now differentiate this. This is the chain function U into V.
Yes, sir.
AP plus
Plus
del
LDP.
L
L
into
into
DAP
DAP
DL.
DL.
Sorry,
L
L
into
L
DAP
into DAP
DL.
DL.
into APDL.
right? Okay. Now L is always positive, right? And this is slope of average product curve. Now average product curves are said to be like this. So in this part, Q less than Q star, what is the value of DAP by DL? 0, positive, negative?
positive.
Positive.
Positive. Now AP is positive. So right. So margin product will be positive over. Okay. Okay. No, focus on. Sorry. Focus on this. Don't write AP. So what is this? AP plus a positive amount. See, this is AP. This is the L slope of AP, which is positive. So where will MP lie? In this part equal to this or here? Simply put, which is greater, MP or AP?
MP.
MP.
Is better.
Okay. Now MPs are also like this. Okay. So in this part, MP is going like this. Q greater than Q star. What is DAP by DL? This part. Average product is declining.
Negative.
So the slope
Negative
is
slope. Negative, sir.
negative. So MP is equal to AP plus L into negative. So AP plus a negative amount. Now which is greater? MP or
Sir,
AP?
AP is greater.
AP is greater.
So AP will be like this. MP will be like this. See, MP can't go on rising, right? Q equal to Q star. This is the maximum. So what is AP? Slope of AP? It is 0. The tangent. Slope is the tangent. So MP is equal to AP plus L into 0. So at this point, we have, sorry, this cannot be there. Right. So tell me one thing, if AP is rising, which is greater, AP or MP?
Sir,
MP.
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 Okay. If MP is rising, which is greater?
MP.
Sir, MP is greater.
MP.
If MP is falling,
Sir, AP
Initially
is
it is
greater.
greater, but then AP becomes greater.
MP is falling from this range. So we cannot say this part, MP is greater, here MP is equal. Don't forget this point. And here MP is lower. So this is a very favorite trick question. So we can ask you that what is happening if AP is going up, MP is coming down, and then what is the relation between AP and MP? Or we can simply ask that AP is greater than MP. What is the slope of the MP curve? Or what is the slope of the AP curve? So remember this derivation and the resultant diagram. Now, we can also get something very similar. If we look at the marginal cost and average cost functions. Actually, what we have is um, the total cost comprised of two things. One is fixed cost, the other is the, so this is the cost which is incurred even if you don't produce anything. And this part depends upon the level of output. So for instance, before you begin production, you require a land, you require a building, right? And even if you don't produce anything, you still have to incur these costs. You'll have to pay the rent for the land, you'll have to pay the rent for the building, you have to purchase the equipment. On the other hand, if you look at electricity, raw materials, roughly, I mean, if you increase your level of production, your electricity consumption is going to go up, your raw material consumption is going to go up. Labor is assumed to be a variable cost. But do you think labor really is a variable cost?
So at times it can't be.
How?
So when there are the permanent laborers,
Yeah. If you have permanent workers who are paid a
this
monthly rate,
has to be
W,
permanent.
per month, whether your income produce something or not, you still have to pay this. But
Ayush,
in economics, sorry. But in economics, we assume that labor is part of the variable cost. Now, if we take marginal cost, how do you define it in terms of differentiation? DTC by DQ, right? Now, what is DFC by DQ?
0.
0.
0.
So that means marginal cost is a depends on simply the variable cost and its changes with output. Fixed cost doesn't enter into marginal cost. Now, what is the relation between marginal cost and average cost? Remember that they are both U-shaped. Okay, let me take the roll call. Poonam Chaudhary, Deepika Paul, Deepika, Sneha Shutrathar,
Present, sir.
Shantika, Orit Shaha,
Yes, sir.
Akanksha,
Present, sir.
Uponita Barman,
Present, sir.
Sajid,
present, sir.
Oindrila Mukherjee,
Present, sir.
Kritika is present, Anandarupa,
Present, sir.
Present, sir.
Prithviraj,
Present, sir.
hmm, Anushka Pal,
Present, sir.
Shantanu Porai, present.
Present, sir.
Aryan Singh came in late.
Present, sir.
Ria Ratan left. Okay. Arpan Thapa,
Present, sir.
Rajdeep Basu,
Present, sir.
Rajashree Khan, present.
Present, sir.
Vaibhav Agarwal, you asked a
Present, sir.
question. Srija is there.
Present, sir.
Sanveer Alam,
Present, sir.
Oishani,
Present, sir.
Shaumo Priti,
Yes, sir. Present.
Rajashri,
Present, sir.
Simran.
Present, sir.
Okay. Otri,
Present, sir.
Gunjari,
Present, sir.
Khushi was there. Sreyash Das left. Aditi Marik,
Present, sir.
Orpita Chanok,
Present, sir.
Deeptasri.
Present, sir.
Okay. Have I left out anyone?
Yes, sir.
Yes, sir.
I'm Soumya.
So I'm out.
Shoma. Wait a minute. Orgo. Okay. Shomo, Orgo. Anyone
Sir,
else?
Abhishekta.
I didn't get your name, please.
Sir, Abhishekta.
Abhishekta, yes. Okay. I don't think I've left anyone else. Okay. Yeah, Aryan Singh, do you want to ask
Yes, sir.
anything?
No, sir. No, sir.
Okay. You just wanted to experiment with raising your hand. Okay. So now the
Sir,
question that I
actually,
want to.
did it by mistake.
Okay, anyway, don't worry. Okay. See, what I want to ask you was that we have derived the relation between marginal cost and average cost. So I'm leaving it to you as a homework that try to find out what is the relation between marginal cost and average cost. Remember, both are U-shaped. That is one. The second thing is, one second. If you go through Hoy's book, you will see that I've left out
স্যার
large
আগের কোশ্চেনটা
sections of
একবার রিপিট করবেন?
average cost হচ্ছে what is the relation between marginal cost and average cost? When is MC greater? When is AC greater? Draw it just as I've drawn it for the NP and AP curves. Second is that if you go back to chapter 3 of Hoy, you will see that I've left out uh, section 3.3, which is present value comparisons. So subsequently again, we define present value from page 87 onwards. So section 3, 3.3 and 87 onwards. So I would like you to go through this, and if any of you have a problem, I think some of you are shy and don't want to reveal that you have difficulty, just email me. You don't have to say anything in class, but just identify, giving the page number and paragraph, exactly where you have a problem. Once you go through this chapter, these two sections, we will discuss some questions which are given in the end of chapter 3, particularly from 3, question number 3, 5, 6, 7. Okay, this is one. And second is, we are planning to hold a exam next week, shall we say? Next week, the second day of that is Tuesday, Wednesday, next Wednesday.
So Tuesday will be okay.
টিউসডে তো আমি ক্লাস নিচ্ছি না, ওটা তো এমডি নেবার কথা।
Then sir, Wednesday.
হ্যাঁ, তো if I take it on Wednesday, it will be something like this. The process will be something like this. You have to, I'll mail you the questions. You'll have to write out the answers and scan the pages and send it to me. Mail it back to me. So I'll give you 1 hour, depending on the question, on solving. Downloading, though, it won't take too much time, and I'll take some time to give you to upload the questions. So if you can get hold of Cam Scanner, that is a fairly good package which can help you to scan using your mobile.
Sir, Cam Scanner is banned now?
Sir, it is a Chinese brand, sir.
Sir, Dog Scanner is there.
হ্যাঁ, তাহলে ডক স্ক্যানার নিই না। ক্যাম স্ক্যানার
Cam
ডাউনলোড
scanner
হয়
still
না।
works actually.
Cam scanner
No,
Scanner
sir,
is the
it works. It works. It's the
yeah,
best
Zoom is
actually.
also working.
Yeah.
So the questions are coming from the mathematical part only or micro part
No,
too?
it will be applications.
Okay, okay.
Applications.
So could you tell us the proper syllabus?
Proper syllabus is like, see, whatever applications I've done, I will cover it. So like elasticity, the marginal product, average product, the problems that I've discussed in class, and the problems that I told you just now in chapter 3.
Okay, sir.
So which book should we refer to?
Which book? Well, Hoy's book is one, but you won't get the elasticity and others for Hoy. Let me see, Chiang. No, Chiang actually starts a bit later. No. Right now, you can go through Hoy's book, and for elasticity, average product, those derivations, you'll have to refer to the videos. Don't worry, it will be, since it's the starting exam, it will be easy.
So the test is on.
Yes, it
So
will be on Wednesday.
So will we be marked on based on this exam?